to now, we've talked about histograms, polygons, ogives, and more recently, stem and leaf plots. So all of those things are graphical summaries of data. So we were summarizing data using a graph or a picture. Today, we're going to talk about the very first numerical summary of data. So we're going to summarize data using a number instead of a graph. You've seen examples of these in your daily life. So throughout your academic career, you're going to take lots of different classes and you'll get lots of grades in those classes. So your transcript is going to have all the classes you've taken and all the grades that you got in those classes. And then there's also a GPA. So the GPA summarizes your entire academic career into a single number, right? That's a numerical summary. Another example for my sports fans, a quarterback, right? A quarterback's performance is dependent on lots of different things. You know, how many passes they complete, how many yards they throw for, how many interceptions they throw, how many turnovers they commit, how many touchdowns they throw, and whether they win a game. So all of those things is summarized into a single number called a quarterback rating. So today, we're going to talk about measures of center. So these are going to be numbers that tell us something about the center of our data. The first one is called the mean. The mean we've all seen before. The mean is another name for the average. Find the mean of the exam scores 78, 83, 92, 68, and 85. So I think we all know how to find the average. You add up all the data values, and then you divide by how many data values you have. So we're going to add up all the data values. And then divide by how many data values we have. So we have 1, 2, 3, 4, 5. Okay, so up top, 78 plus 83. 78 plus 83 plus 92 plus 68 plus 85. So up top, it's 406. And then we're going to divide that by 5. So 406 divided by 5, 81.2. Okay, that's the mean of these exam scores. So some notation. If you calculate the mean using data that you got from everybody in the population, the symbol is that. So that's a Greek letter mu. If you calculate the mean using data that you got from a subcollection of the population or a sample, the symbol is x bar. Now, I would really like the mean, right? So if I could get data from everybody in the population, that's great. That's really what I want. But in reality, remember the theme of statistics is that we can't get data from everybody in the population. There's just too many people. So instead, we're going to take a sample, take a smaller subcollection of the population, calculate the mean from the sample, and then the hope is that if we do things correctly, x bar is going to be a good approximation to mu. Okay, the next measure of center is the median. The median is just the middle number. After you put the data in order. So part A, negative 20, 15, 21, negative 20, and 19. So I'm going to put my data in order. So in order, it should be negative 20, negative 20. What's next? 15, 19, and then 21. So after you put the data in order, the number that's in the middle is the median. In our case here, the number in the middle is 15. So this is the median. So actually, let me clarify. When I say the middle number, I mean the number so that half of the data is above it and half of the data is below. So let me actually include that here. Okay, so 15 is the median because there's 2 data values above it, and then there's 2 data values below it. Another situation that you might run into is part B. So part B, let's put this in order. So in order, what goes first? I think negative 31 goes first. So it's going to go negative 31, and then negative 23. And then what? 10, 28, 28, and then 31. Now, what's different about part B compared to part A? In part A, after we put the numbers in order, there is a number like right smack in the middle. Part B, we put the numbers in order. Is there a number in the middle? No, right? So it's not going to be 10 because there's 2 below and there's 3 above it. It's not going to be 28 because there's 3 below and 2 above it. So part B is a situation where there's not a number in the middle. Okay, so what do? What you do is you take the 2 numbers in the middle, which is the 10 and the 28, and then you're going to average them. So add them up and divide by 2. So we're going to take 10 plus 28 and divide by 2. So 10 plus 28 is 38, and then divided by 2. 38 divided by 2 is 19. Okay, so 19 is our median. So notice that there are 3 numbers above 19, so 28, 28, and 31. And there's also 3 numbers below 19, 10, negative 23, and negative 31. Okay, so once again, half of the data is above it, and half of the data is below it. The third measure center is called the mode. So the mode is just the number that occurs most frequently. Okay, look at your data and look at which data value occurs most frequently. Part A, 360118011. So which data value occurs most frequently? I think it's 1, right? So 1 occurs 4 times. So it's going to be 1. Part B, 4741656. What data value occurs most frequently? Here we have a tie, right? 4 occurs 2 times, 6 occurs 2 times. So if there's a tie, then both of them are modes. So our modes here are 4 and also 6. Part C, 485963. What data value occurs most frequently? So here it's all tied, right? So everything occurs only once. So if it's all tied, then there's actually no mode. Okay, so let me throw it back to something we talked about in section 2.2. So when we talked about distributions and histograms, so if we have a distribution, which is a table, it's really easy to find the mode. So the mode is the data value that occurs most frequently. So here, if we look at the frequencies, just look at the highest frequency, which is 22. So this is saying that the 2 occurs 22 times. The 2 occurs most frequently. So here, the 2 is the mode. In a histogram, it's also easy to find a mode. Okay, the mode is just the highest bar. Okay, so here the highest bar is this one, which represents 2. So 2 is the mode. Okay, which is the reason why when we talked about the shape of a histogram, and we talk about modes, right? The modes refers to the peaks as in the highest bar. So the highest bar represents the highest frequency, and the highest frequency is the mode. The next thing I want to talk about is the relationship between mean, median, and extreme values. I'm going to start off with an example. I'm going to pick some numbers here. The numbers I'm going to pick are 3, 10, 18, 25, and 50. And I'm going to find the median and the mean for this set of numbers. To find the median, put the numbers in order. I think the numbers are already in order. So they're already in order. Pick the middle number. The middle number here is 18. So the median is 18. The mean, to find the mean, I'm going to add this up and then divide by however many data values I have. So 3 plus 10 plus 18 plus 25 plus 50 is 106, and then 106 divided by 5. So 106 divided by 5 is 21.2. Okay, what I want to do now is I'm going to replace one of these numbers by an extreme value. So an extreme value is just a number that's way bigger or way smaller than the rest of your data. Okay, so I'm going to replace one of these numbers with an extreme value. So I'm going to replace the 50 with an extreme value. So this is going to be a number that's way bigger than the rest of my data. So what number should I pick? I'm going to pick 371. And then I'm going to find the median and the mean again. So the median here the numbers are already in order. The median here is 18, the middle number. The mean I'm going to have to calculate, so add up the data values. So 3 plus 10 plus 18 plus 25 plus 371, that's 427. And divided by however many data values I have, so 1, 2, 3, 4, 5. So 427 divided by 5 is 85.4. Okay, what's the point? So the point I want to make here is when I replace, so this is my extreme value. So when I replace one of my values with an extreme value, what happens to the median and what happens to the mean? So the median went from 18 and it stayed at 18, right? So the median stayed the same. What about the mean? The mean originally was 21.2. Then with an extreme value added, it jumped up to 85.4. Okay, so the point here is that the median is not affected by extreme values. The mean is affected by extreme values. Okay? And the median is not affected. And having just one extreme value changed the mean by a lot. Right? It went from 21.2 all the way up to 85.4. So another point I want to make here is when you're deciding which measure of sensor to use, the mean or the median, if your data set has extreme values, you probably want to use the median because it's not affected by the extreme values. If your data set doesn't have any extreme values, then you might want to use the mean. Okay, so as an example of this, when we talk about income in a city, typically you'll see people talk about the median instead of the mean. And that's because income in the city does have extreme values. Right? So most of the people in the city, their income is in a certain range. And then you have the few people who are multi-millionaires in the city. So those are the extreme values. Same thing for housing prices, right? When we talk about housing prices in the city, you typically see people use median instead of mean, and for the same reason, because housing prices, there's extreme values, the giant mansions in the city. Okay, next up, mean, median, and the shape of data. So this shape, right? The peak is here, and then you have a tail on the right side. So you remember back when we talked about histograms, that's called skewed to the right. And the point the picture is trying to make here is when you have data that's skewed to the right, notice where the mean is. Is it to the right or to the left of the median? It's to the right, right? So when data is skewed to the right, the mean is to the right. Okay, and the reason for that is the peak, most of your data is on the low side, and then you have a few data values on the high side. So these few data values are the extreme values. So if you have extreme values on the high side, it's going to affect the mean by pulling it upward. So you pull it upward means to the right, then your mean is going to be to the right of your median. Picture right here, the tail is on the left side. So if the tail is on the left side, it's called skewed left. When your data is skewed left, the mean is to the left of the median. Okay, and for the same reason, in a skewed left picture, most of your data is on the high side, and then you have a few on the left side. So the extreme values are on the left side, and the extreme values will affect the mean by pulling it left or downward, which is why the mean is going to be to the left of the median. And then the picture in the middle is the peaks in the middle, and then you have equal tails on both sides. This is symmetric. So in a symmetric picture, this is saying that the mean and the median are about the same. Okay, so now let's use these facts. Example 1. So use the properties of mean and median to determine which are the correct mean and median for the following histograms. This histogram, is that skewed left or is that skewed right? So skewness refers to the location of the tail, right? So this is the tail. The tail is on the left side, so this is skewed left. Which we know now means that the mean should be to the left of the median. Okay? So that should allow us to rule out two of these choices. So look at B. Mean 5.4, median 4.6. Okay, in this situation, mean is not to the left, right? 5.4 is to the right of 4.6. So it can't be B, because I expect the mean to be to the left. And we can also rule out part C. Okay, 6.2 is to the right of 6.1. So now we're down to part A and part D, or choice A and choice D. So to figure out between A and D, think of the mean. Oh, okay, let me back up. Have you guys, do they even have this anymore at playgrounds? you guys ever play seesaw at a playground? So think of a seesaw. Think of a seesaw. So like this horizontal is this bar, and think of the bars here as blocks of wood. The mean is going to be the location where the seesaw is going to be balanced. Okay, so the mean represents this thing. I think it's called a fulcrum. Don't quote me on that. So it's going to be the place where it's balanced. Okay, so of our choices, 5.9 versus 4.2 for the mean. Could it be 4.2? So 4.2 would be right there. Okay. Would this blue horizontal bar be balanced, or is it going to tip over? So I have a whole bunch of big blocks on the right side, and I have about the same number of small blocks on the left side. So obviously it's going to tip over to the right side. Okay, which means D is not the right answer. So 4.2 is not going to be the mean. Part A, 5.9, which is right here, this has a better chance of being balanced because I have a few big blocks on the right side, and I have smaller blocks on the left side, but I have more smaller blocks. So at 5.9, it's more likely to balance. Right? A few big blocks on the right side, and then more small blocks on the left side. Okay, so it looks like it's going to balance at 5.9, which means A is going to be the answer. Next picture. Is this skewed left or skewed right? Location of the tail. The tail here is on the right side, so this is skewed right. Which means I expect the mean to be to the right. Okay, which should allow me to eliminate two choices. So which choices can I eliminate? I need the mean to be to the right of the median. So which ones can I eliminate? I can get rid of B, right? Because 2.1 is to the left of 2.3. What else can I eliminate? I think D, right? 3.2 is to the left of 4.2. Okay, so of the two that remain, we're going to look at 4.2 versus 2.2. Okay, at which place, the mean, at which place is it more likely to be balanced? So this is the horizontal plank. Where should I place the fulcrum so that it's balanced? Is it 4.2, which is right here, or at 2.2, which is right here? Where is it going to tip over, and where is it going to be balanced? So I think at 4.2, it's obviously going to tip over to the left side because I have all these big bars to the left, and then I have a few small bars to the right. So I think at 4.2, it's obviously going to tip over to the left side. So it's not going to be A, it's going to be C. Because at 2.2, you have a better chance of balancing. I have like two big bars to the left, and then I have a bunch of other smaller bars to the right, but there's more of them. So it's more likely to balance at 2.2. So C is the answer. Example 2. A report states that the mean household income last year for a certain city was $50,100, and the median was $39,500. If a histogram were constructed for the incomes of all households in the county, would you expect it to be skewed to the right, skewed to the left, or approximately symmetric? Let me put these two numbers on a number line. The 39,500 should go on the left side here. 50,100. And then let me label what these things are. So the 50,100 is the mean. The 39,500 is the median. And then now the question is this skewed left, skewed right, or symmetric? So we take a look at what we just talked about. If it's skewed right, the mean is going to be to the right of the median. If it's skewed left, the mean is going to be to the left of the median. So where's the mean? Is the mean to the left or to the right? The mean is to the right of the median. Okay, which means this is going to be mean to the right, skewed right. This is going to be skewed to the right. And that's because the mean is to the right of the median. Example 3. In a study of Facebook users conducted in 2012 by the Pew Research Center, the mean number of Facebook friends per user is 245. If the data is skewed to the left, would you expect the median to be greater than, less than, or approximately equal to 245? We're only given one number here, 245, so let me put that on a number line. What is this number, 245? Is that the mean or the median? It's the mean. And the question here is, where do you put the median? Do you put the median on the left side, or do you put the median on the right side? And I want the data to be skewed left. So if the data is skewed left, the mean is to the left, okay? So the mean should be to the left. So where should you put the median so that the mean is to the left of the median? Do you put the median right here, or do you put the median right here? I think you would have to put the median right here. Okay, if I put the median right here, then indeed the mean is to the left of the median, like I want. So I think this is going to work. And what does this mean? Does this mean that the median is greater than, less than, or equal to 245? So if the median is here, then it's greater than. Example 4. According to the National Vital Statistics reports, the median life expectancy in the US was 83.5. If the data is skewed to the left, would you expect the mean to be greater than, less than, or approximately equal to 83.5? We're only given one number here, 83.5. Is this number the mean or the median? This number is the median. And the question here is, where should you put the mean? Do you put the mean right here on the left side or on the right side? And remember, we want the data to be skewed left. Okay, if I want data to be skewed left, the mean should be to the left. So mean should be to the left. So where should you put the mean so that it is to the left of the median? I think you'll put it right here. Okay, so mean is to the left of the median, like I want. And then what does this mean? This means that the mean is less than. $83.5. Finding the mean from a frequency distribution. Example 5. A group of people were asked how many siblings they have. The data is summarized below. Find the mean number of siblings of the group. If I give you raw data, you know how to find the mean. If I give you the raw data, you just add up all the data values and then divide by however many data values you have. How do you find the mean if I give you a table? Do you just add up these numbers and then divide by however many numbers you have? No, you don't. You have to think about what is this table telling you about the original data. What does this 15 mean? This 15 means that there's 15 people who have 0 siblings. There's 21 people who have 1 siblings. This table is telling you about what the original data looks like. So it's telling you that in the original data, there's 15 zeros. There's 21 ones, there's 17 twos, and there's 11 threes. So you have to use a table to go back to the original data, and then from the original data, find the mean. So this is telling me that the original data is 15 zeros. So there's 15 zeros. There's 21 ones. Seventeen twos. And then 11 threes. This is the original data. So you find the mean using this original data. So add up all these numbers and then divide by however many numbers you have. So add up all these numbers. You could go 0 plus 0 plus 0 plus 0 plus 0 15 times, or that's the same thing as saying 0 times 15. 0 times 15. You could go 1 plus 1 plus 1 plus 1 21 times, but that's the same thing as 1 times 21. You could go 2 plus 2 plus 2 plus 2 times 17 times, or you could go just do 2 times 17, and then 3 times 11. Okay, that's adding up all these original data values, and then you're going to divide by however many data values you have. So there's 15 of these, 21 of these, 17 of these, and 11 of these. So in total, you have 15 plus 21 plus 17 plus 11 data values. And then let's do this on a calculator. So up top, 0 times 15 plus 1 times 21 plus 2 times 17 plus 3 times 11 is 88. On the bottom, 15 plus 21 plus 17 plus 11, 64. And then 88 divided by 64. And then round it to 3 decimal places, this is 1.354. Example 6. This semester, Emily got a C in English, a B in biology, and an A in statistics. Find Emily's GPA. So the point I want to make here is that GPA, finding your GPA is actually the same calculation as this that we just did. Okay? So let me write her grades. So she got a grade, she got a C in English, a B in biology, and an A in statistics. Now, an A, you get 4 points. Right, an A, you get 4 points. A B is worth 3 points. A C is worth 2 points. A D is worth 1 point, and then an F is worth 0 points. Now, the units, the C was in English. The English was 3 units. The B was in biology, which was a 5-unit course, and then the A was in statistics, which was a 4-unit course. So what I want to point out here is that the calculation is the same thing as what we just did here, right? The units is just frequency, right? Think of units as the frequency. And then the way you calculate GPA is, this is now a table that looks very similar to this one. And so to find the mean here, you do exactly what we did in example 5. Okay, so I won't go through and finish off this, but after you set this up as a table like this, the calculation is going to be exactly the same as example 5. Example 7. The frequency distribution below summarizes employee years of service for a certain company. Find the mean number of years of service. So we know that if we have a table, we can't just add up all the numbers and then divide by however many numbers there are, right? We have to think about what this table is telling me about the original data. Okay, so what is this table telling me? There's 5 people who have between 1 and 7 years of service. There's 12 people who have between 8 and 14 years of service. So what's the difference between this example and example 5? In example 5, I know that there's 15 zeros. Okay, here I know there's 5 numbers between 1 and 7. So I don't actually know exactly what those numbers are. I just know that they're between 1 and 7. So that's why we have to actually approximate on it in this situation. So what I need to do first is find the midpoints. And as a reminder, the way you find midpoints is back in section 2.2. Midpoints, lower plus next lower divided by 2. Okay, so lower plus next lower divided by 2 is going to be 1 plus 8 divided by 2. So 1 plus 8 is 9, and then 9 divided by 2 is 4.5, I think. Now from here, you could go 8 plus 15 divided by 2, but let's look at what these numbers are going up by, right? So 1 to 8, 8 to 15, 15 to 22, these numbers are going up by how much? They're going up by 7, right? These numbers are also going up by 7, which means everything in this table is going up by 7. So instead of doing 8 plus 15 divided by 2, I'm just going to go up by 7. So 4.5 plus 7 is 11.5 plus 7 again, 18.5 plus 7 one more time, 25.5. Okay, so the idea here is I know there's 5 numbers between 1 and 7. I don't actually know what those numbers are. So the next best thing is we're just going to assume that all 5 numbers are the midpoint. Okay, all 12 numbers are the midpoint. So we're going to approximate that the data is there's going to be 5 4.5s. There's going to be 12 11.5s. There's 21 18.5s. And then there's 10 25.5s. So that's my original data for finding the mean. So to find the mean, we're going to add up these. So you can go 4.5 plus 4.5 plus 4.5 5 times, or that's the same thing as saying 4.5 times 5. 11.5, 12 times. That's going to be 11.5 times 12. 18.5, 21 times. That's going to be 18.5 times 21. And then 25.5, 10 times. That's 25.5 times 10. And then divide by however many data values you have. So you have 5 of these, 12 of these, 21 of these, 10 of these. So in total, you have 5 plus 12 plus 21 plus 10 data values. Okay, so up top, 4.5 times 5 plus 11.5 times 12 plus 18.5 times 21 plus 25.5 times 10. Okay, up top it's 804. On the bottom, 5 plus 12 plus 21 plus 10, 48. And then 804 divided by 48, 16.75. Example 8. A researcher asked a sample of people how far they live from the Sacramento International Airport. Their responses are summarized in the histogram below. Find the median, find the mean. How do you find the median from a histogram? Let's go back to what the median means. So the median is the middle number, but it means half of the data is above it and half of the data is below it. So we're looking for the data value so that half of your data is above it and half of your data is below it. So the possible data values are these numbers down here. Okay, let's just kind of guess first. Could it be 45? Could 45 be the median? Well, how many data values are above it? These are the frequencies, right? Frequency means they're counting how many data values are in each range. So if I add up these frequencies, 4 plus 3 plus 2, that's 9. So that tells me how many data values are above 45. How many data values are below 45? Well, 12 plus 3, 15. So there's 9 above and 15 below, right? It's not the same above as below, so that's 45 is not going to be the median. And then from here, you kind of just guess and check these numbers. Could it be 30? Okay, how many data values are below? 12. How many data values are above? Well, 3 plus 4 plus 3 plus 2. 3 plus 4 is 7, plus 3 is 10, plus 2 is 12. So there's 12 above, and there's 12 below. All right, it's the same above as below, so 30 is going to be the median. And that's because there's 12 above and 12 below. So just guess and check these numbers until you have a number that has the same frequency, total frequency above as below. What about the mean? Well, the mean, we know how to find a mean if we have a table. And we know how to go from a histogram to a table. So that's the idea. We're going to go from a histogram to a table, and then we're going to do exactly what we did in example 7. So let's first make a table. Okay, so how do I go from a histogram to a table? Well, I first have to make the ranges, right, which are the classes. And we have to remember the numbers down here are the what numbers? The lower, the uppers, the midpoints. On a histogram, the numbers down here are the lowers, which means they are the lower number of each range. So my ranges are going to be 15 to something, 30 to something, 45 to something, 60 to something, 75 to something, and 90 to something. Okay. How do you find the uppers? Well, just look at the next lower and just go slightly below it. So what number is slightly below 30? 29. So since we don't have the original data, I don't know how many decimal points to put on here, so 29 is fine. You could also go 29.99 or 29.999. Right? It doesn't matter here. The next upper should be slightly below 45, which is 44. The next one should be slightly below 60, which is 59. The next one is slightly below 75, which is 74. And then the next one is 89. And then this last one, the easiest way to find this last one is just to figure out what your numbers are going up by, right? 15 to 30, 30 to 45, 45 to 60. These numbers are going up by 15, right? These numbers are also going up by 15, right? This is the class width, which means this last one should also go up by 15. So 89 plus 15 is 104. Okay, the frequencies. This is a frequency histogram. So these numbers are the frequencies. So 12, 3, 4, 3, 2. Okay, and I didn't need this last one anyway. All right, so this is a frequency table, frequency distribution. And then from here, to find the mean, do whatever we did in example 7. So you're going to find the midpoints and then do whatever we did in example 7. Okay, so that's all I have for you today. Have a good day. See you next time.